Welcome to this video tutorial on drawing functions that satisfy a particular domain and range. As we see in this problem, we have a domain and range provided. We will graph this function, or a function that satisfies this set of criteria, as well as a second function in this problem. Perhaps you would like to hit pause and try to draw a function having these criteria before listening to the remainder of this video. But now what we're going to look at in this video is how we could draw this. So the domain goes from negative infinity up to negative 2. We need to have that portion. And the domain also goes from negative 2 up to 4. It has that little break though at x equals 2. So we will need to be in the yellow highlighted regions. Then to satisfy the range, it has to be between negative 5 and negative 1 for the y values. So it'll come in something like this, negative 5, negative 1. And it also has to span from 1 to 5. So it'll go like so, up above. Now we need to make sure that we get a graph that does each of those things. So when we graph it, we're going to look over here. Notice it goes all the way to negative infinity, but the range does not go to positive or negative infinity. So we're going to have something where we have a horizontal piece of a line, like I'm placing right now in magenta on our grid. Once we get that, we have to be able to take care of the values from 1 up to 5. So we could do something, I don't know, we need to do something like this. We could go up to 5. Remember, there has to be an open dot because we're missing that x value at negative 2. Now we have to go down all the way, and we don't want anything that appears to be a vertical portion of a line, but we have to go without a vertical portion of a line all the way down to that y value of 1. We got to get that in there. So I'll do it like this. Boom. That would get us to the y value of 1. Then that would take care of this piece of the range and part of the domain. Now we've got to finish off the domain and take care of the rest of the range. So we could do something like this where we have an open dot down here, and then we could kind of come up like so, whoop, up to here. That piece would take care of the range from negative 5 not included up to negative 1 included, and it would take care of the rest of our domain. So now if we remove the color coding, there, color coding is gone, this graph should satisfy the domain and range provided. Look at the picture. It does work. Our domain is negative infinity up to negative 2 with a problem spot. Then negative 2 over to 4 takes care of the domain. The range goes from negative 5 with an open parenthesis up to negative 1 with a closed parenthesis, and then from 1 with a closed parenthesis up to 5. Now there's a variety of other ways that you might be able to graph this particular function. This is just one method that works. Think it through however you might like. Here's our second problem that we're going to consider. Perhaps you would like to hit pause and try it out before we proceed. This time I'm only going to really highlight the range. So we need to be from negative infinity up to negative 2. So it needs to go like this. And then from negative 2 up to 1. So it needs to go like this, but we have that little break in there that I'm going to leave and make sure I remember. Then we go from 1 to 6. 1, 2, 3, 4, 5, 6 would be up here. And then we go from 6 to infinity. Okay. So there's really just some little spots that we're missing if we're doing this. For example, we're missing here, we can't have anything at y equals negative 2. We can't have anything at y equals 1, and we can't have anything at y equals 6. So now when I go to draw the rest of this, let's try to draw it carefully. So this negative 7, 1, 2, 3, 4, 5, 6, 7. I can put that y value anywhere except for those spots that I'm not allowed. I'll put it right there. Then from negative 5, 1, 2, 3, 4, 5, up to negative 2, I can fill any of this stuff in. What if I did something like this? Open dot here, open dot here, connect them like so. That would still pass the vertical line test. And as far as the range goes, it takes care of everything from 1 to 6. It would also take care of these items, except I still need to get that y value on the graph. Let me get it on the graph right there. Sweet. Then I've got that x value. for x equals negative 5 placed at y equals 3. Now we've got the span from negative 1 to 2 with x values. So over here, why don't we do something like this? Negative 1 over to 2, connect those two dots. That would now take care of this portion of our range, negative 2 to 1. It would also take care of this portion of the domain. And now from 4 to infinity, we'd have to take care of each of those other pieces. Here's a strategy that might be helpful. What if we broke out a vertical asymptote somewhere 1, 2, 3, 4 after x equals 4, like right here? Then what we could do is we could have something like this, where, let's see, we need to go from negative infinity up to negative 2. Oh, we could do something like this, have an open dot here, and have it go down to infinity. Now that is going to pass the vertical line test. It's an asymptote. It's not purely a vertical line. And then we could have something similar coming up here, where we have a vertical asymptote, and then it can spin around, come back, and do something like that. Now hold on, you might be saying, we need to make sure we have all y values from 6 to infinity, but I don't have it by what I just drew. So we will need to fix that up. What we could do is we could have something come in here like this. We can put an open dot here, and then we can come back up, and I'll continue like so. That would be good. We'd still have to fill in that open dot somewhere. I could do it right here. And I know it's a little bit off the grid, but that's not the end of the world. Now when I look at this, I've taken care of all y values from 6 to infinity, but I don't have 6 on the graph. X values, I needed from negative 4 up to infinity. So 1, 2, or positive 4 up to infinity. 1, 2, 3, 4. I need to fill in a y value somewhere on x equals 4. So let me put it right here. And then there's one more problem. Can you notice what one other thing I have yet to do? Well, we are missing an x value at x equals 5. So if I put a dot right here, that should be good to go. Let's get rid of the highlighting and analyze this and see if we can make sense of it. Now again, this is not the only way that you could draw this graph. So think about it, try things out, and see how you have to modify them as you go. So as we look this over from left to right, I've got an x value at negative 1, 2, 3, 4, 5, 6, 7. I needed that. Then x values from negative 5 included up to negative 2 excluded. Took care of that. Then x values from negative 1 excluded up to 2 excluded. Took care of that. And then x values from 4 included up to infinity included. And these little dots filled in the spots that we're missing, I have now taken care of that. For the range, negative infinity, see this arrow going here, up to negative 2, sweet, we have that particular y value missing, so I can get rid of this dotted line. We don't have that y value. We also have a y value missing at y equals 1, which we wanted to be missing. And finally, we have a y value missing right there at y equals 6, which we wanted missing as well. Now please make sure you label your axes. So the other thing you need to make sure you do is put the x-axis label and the y-axis label. And we do have that vertical asymptote that we can leave as we see. This is one example of a graph that would work. Just think it through as you go. And really, if we gave you a graph and asked you to identify the domain and the range, you would probably be okay with it. Think about how you can work in the reverse direction. Keep some of the tricks we discussed in mind, and hopefully it will work out for you.